Hi friends, I'm Dan Sedlacek. I'm from Facebook, and I'm here to talk to you today about how we manage Windows. As he alluded to, Facebook is very well known for being an open source happy company. We use Linux a lot, but we do use Windows. So I'm here to talk to you about how we do that. Most of the focus will be on clients. So if I refer to a node, think about a laptop. It ends up being the more interesting aspect of the story. But I'll give you a little bit of background on myself. So I'm a Windows system administrator. To this day, I do not have a single Microsoft certification. I don't have a chef certification either. So I guess take my words with a grain of salt. But before I worked at Facebook, I worked in academia. I worked at my alma mater, the University of Wisconsin in Madison. There's a very young photo of myself right there. I have more hair, less beard, and coincidentally, that picture was one of the first photos of me on Facebook. To get that picture taken, it was taken at an American football game at my alma mater, and I paid for the ticket by working at my student hourly job, which had a traditional background in managing Windows systems. So at that job, I used Active Directory, I used group policy, and then I also used SCCM, and then we may have had an instance of SCOM running around for metrics. But in 2014, I joined Facebook, and that was about when my entire life changed. I had to move to California, and then I got a job at one of the most preeminent tech companies in the world. I worked at Client Platform Engineering. That is the Client Platform Engineering manages laptops, it manages mobile devices, and they have a great deal of scale to worry about. Currently, I'm a member of the core automation team. Our acronym is CAT. So that is a more holistic viewpoint of what our infrastructure is. So working on Client Platform Engineering, I'll refer to them as CP from now on. That was a good introduction to running stuff at scale for us. When I had to take a step back, I'd also have to take ownership over infrastructure. So when I'm taking ownership over the infrastructure, the footprint isn't nearly as big. So the transition was actually easier for me because now I had to worry about servers. The challenge with managing laptops is a server doesn't have legs. It can't hop on a plane and be across the world. So it's a lot more of a complex thing to have to manage. So a high-level overview of some of the stuff we used to do that with is Chef. We're well known to be a very heavy Chef user. We also use PowerShell. Who can't use it these days? You can't be a Windows administrator and not know it. Is that me? Oh. Let's just do that. There we go. Sorry. Okay, so for software deployments, we use Chocolatey. It's a really great tool. It's simplified a lot of problems we had with SCCM when it came to software deployments. It's a great tool. If you haven't used it and you haven't checked out Rob, find him, talk to him. He's a cool guy. For reporting, we use custom Chef handlers. At the very end of a Chef run, you can actually just have it pipe data to wherever you want if you know how to write Ruby. We also use OS Query. OS Query is a Facebook tool that was written. It's open source. It's basically SQL-like syntax to query the state of a system. You might scoff a little bit and go, hey, we've had WMI since Windows XP, which is true. But this tool in particular is a way for people to meld multiple platforms together. So you can look at network routes on any platform. It's the same query across all of them. And then you can pipe the data into some other data source that you use to do aggregation or analytics. For source control, we use Facility, another open source product. It was started by a former Facebooker. Now that's his day job is to run Facility. There's a couple components to it. One of it is called Fabricator. That's a web endpoint that we use to do code review. And then there is another command line utility that's kind of a wrapper. It's called Arcanist. And that merges the ability to have a very similar development workflow for Mercurial, Git, and SVN. So for our configuration management philosophy, we borrow a lot of this from production. So there's actually a well-known GitHub that has a lot of our production tools, and they have a philosophy markdown file that we steal a bunch of our stuff from because we interface with our production engineers a lot. Because they handle this stuff at scale. It might be in Linux, but the principles are very much the same. So one thing that we have to do is we make our stuff idempotent. That just means you only change on a delta. So initial runs might be very, very slow. And then when you only have to change the things that have changed, hopefully nothing has changed and things go very quickly. Our other philosophy is for everything to be extensible. So our configurations need to be adaptable to multiple use cases. We also want them to be flexible because we want them to integrate into existing workflows but not be stringent enough to dictate to other people how to use it. We'll get into that a little bit later with a little bit of a code example. We usually call them API cookbooks. And then the last thing is transparency. So we want our configurations to be easily viewable by anyone. That's why we're putting it in source control. So the nice thing about that is if someone has a question about how a thing is configured, they can just do a grep search for it. You can look at the code. If someone needs to audit it, our security team does every now and then go through some of the configurations and just do a spot check to make sure everything's good. It's super easy to do. And because we're using that facility ecosystem, we go through peer review. Like everything at Facebook is, all of it is peer reviewed. So you can't, much like the VSTS talk that was earlier, someone's got to put a stamp on it. Someone has to actually look at the code. I think for myself, last half I did like 340 code reviews. That is on kind of the, I'm an outlier. Like most people get by doing maybe 30 or 40. But it's a big part of a culture. Like we're always checking everyone else, and that's part of how we manage the systems. So back in 2014 when I joined, things were a bit more traditional in the sense that the tools we were using were mostly provided by Microsoft. So we had an SCCM set up. We used group policy to configure all the endpoints. If we had to do some heavy lifting, we would use Visual Basic. Not exactly the best tool to use for the job at the time, because PowerShell was out there. It's just my team didn't necessarily have exposure to it at the time. If we had to do any kind of reporting, what we would use is we would use the very, I would say it's obscure just because it's so hard to use, but like we would do reporting by doing a deployment. We'd look at the reports in SCCM to see that pretty pie chart on things that have either failed, are pending, or have succeeded. We aggregated all of our logs, so we use Splunk. That gives you like a really easy syntax to search for common events. So scraping the event log was not really that hard. You just kind of had to know what to look for. Our individual team members were very specialized in certain roles. We manage multi-platform environments, so our peers in production have a very homogeneous environment, and we do not. So we manage Mac, Linux, and Windows. It's very challenging to have to do that. So we had a team that is strictly dedicated to Mac. We have a team strictly dedicated to Windows. And then for Linux, very much the same idea. There wasn't a lot of overlap between what people could do. And that was one of the reasons why we wanted to change our workflow. So we also weren't trained how to do source control, which is a very big thing when you're adopting like a tool that is basically all text. So we had come up with a plan to transition ourselves away from SCCM and the way that we were doing things. So to do that, why we wanted to do that, I think, is an important thing to point out, is we had a strong desire to reduce opaqueness in our environment. So we wanted everything to be in source control. If you're editing a group policy, like you go through, you click edit, you navigate a tree, you find the setting that you want, you click a box, you hit OK, and then you wait. And you wait maybe some more. Maybe it doesn't actually get applied and you don't exactly know why, and then you have to go to the event log and figure out why. It wasn't exactly what we wanted as far as like understanding the state of the system. So what we ended up wanting to do, in addition to that, was get rid of the GUI interactions. Going back to what the GPO example is, like you click some buttons, you hit OK, and then you wait. They're inherently inefficient when you're trying to operate at scale. Like if you're navigating a GUI tree, like you have to know what to look for. And the bane of GPOs, and also the advantage, is like there's a lot of settings, and it tells you what the settings are, but you have to find them. So oftentimes I'd find myself going to Stack Exchange, going like, where was that thing? And hoping someone had copied and pasted the direct path into it. Not all the times it was there, and I'd have to hunt, and that was an exercise in futility sometimes, because you can never really find anything when there's like 1,000 settings. So another problem that we had in our environment was testing the group policy was fairly difficult. We have a fairly well-established OU hierarchy. It's just when it came down to testing specific things, you only kind of wanted to test the delta again. So you'd have to move computers in and out of the OUs that we designated as testing OUs. Sometimes you may forget to do that, and then you would wonder why the settings you're trying to test don't get applied. So that was another thing that it personally annoyed me, but I put that on the slide, so now I get to vent to people about it. Endpoint management needed to scale with us as we were growing. At the time I started, we were number N, and then a couple years later, it became N times 2. So Throwing more things at the infrastructure that we didn't have the utmost of confidence in was kind of a thing that we wanted to correct. So we also need a better way to report on these things. So we have Splunk. You can do really pretty dashboards in Splunk, but we wanted something more. We wanted some like near real-time ability to track what was going on in our environment, report on state. We didn't necessarily have that with SCCM. So we came upon a plan to just replace bits and pieces of it. And coincidentally, at this time, we had a transition on our Mac team going from, Casper to Chef. So they had some knowledge to give us on the Windows side of things, like what were their problems when they were deploying it. So we could talk to them and say, like, hey, like, how did you do this? So we actually had a little bit of interchange of knowledge there. And thankfully, Windows Chef Client just added support. So I think it was like version 12.08. It was pretty raw in the beginnings of things, but that was actually just fine for us because we were traditional Windows admins. We didn't exactly know how to write Ruby. We didn't know how to write Chef. So we figured that we would just gradually roll everything out and add features instead of making the decision of saying, like, we must replace 100% of the functionality of SCCM because that would have taken us a very long time to develop. So we also just decided to agree upon a standardized tool set. We went with Chef, and then we got rid of Visual Basic, thank God. And we decided to use PowerShell as our scripting language, so I think I was the only one that had exposure to it. So I taught some of them how to write PowerShell, and they were very thankful because PowerShell is good and awesome and very readable. So I guess the question would be, how did it go? The answer to that is getting the endpoints in was really easy. Getting the bootstrapping process of Chef, we don't use knife. Another thing to point out is we don't actually, there's a portion of Chef where you use versioning. Like, we don't use versioning at all. We submit everything, and we're always on master. So if you break something, you know very, very quickly whether or not something is broken if you have a good alerting mechanisms. So getting everything in there was actually really easy. We just bootstrap a node. We run, coincidentally, we deployed everything initially with SCCM just to get the bare amount of systems in. And then from there, we were pretty much strictly Chef. Writing the configuration as code, that was the actual challenge. So to GPO's credit, like, you edit some things and they have all the settings laid out. You don't really know what's going on there unless you actually know what's going on within the operating system. So a GPO is setting a registry key. It could be calling out to a command line utility. And when it does that, like, you have to understand the operating system at a bit at a deeper level. I didn't personally know what netsh was until I had to start digging more into, like, how the operating system was behaving when you turn on a GPO. It was a pretty good educational experience. And it was also very hard to, like, find some of those settings, much like it was to navigate in the GPO, because you have to translate all of those things into Chef code, which is written in Ruby. If you weren't familiar with Ruby, you'd have to learn that on top of everything else. So another thing that we had to do was we had to keep the existing infrastructure going at the same time we were doing development. So what we did is we split the Windows side into two groups. One group was maintaining what we had, and then the rest of us or the other two of us were working on developing Chef. And then because the Mac guys had completed their rollout and one of the guys had experience with Windows, we borrowed like half of his time. So we got another 0.5 on there. So we actually were able to start developing and getting everything going. Within about 3 or 4 months, we had enough that we were comfortable with doing a deployment. And when we did that deployment, it actually ended up turning up very well because we had just enough to get everything going, and then when it came time to turn up the dial, Chef was adding more features to the Chef client, and we were able to, like, start adding more functionality into it and supplant some of that stuff with SCCM. So what do we have now? It probably took, like I said, a couple months of, like, solid engineering effort, and in the end, we got what we wanted. So we have scalable configuration management. To that point, what we would need to say is that we can arbitrarily add more endpoints. So our Mac fleet actually eclipses the Windows fleet as far as raw number counts, as far as Chef check-ins go. So if we were to add more, it's not a big deal because we already know that the higher number of Mac clients checking in, our backends can actually handle the load fairly well. The code itself drives the configuration. and it becomes more scalable over time. And that's just when you have all the configuration in code, it's standard software development at that point in time. We have a high degree of granularity for dealing with users as well as computers. So what that means is we have user customizations and we have node customizations. We slurp up like some internal data as well, as far as like what network segment are they on? What desk do they sit in? What's their base office? We have a lot of granularity when we need to target things. So a node customization could be set. It would follow a particular computer name around. A user customization would be something that would follow a particular user around. And we control all of that. We can also pull in groups from group policy by doing an LDAP query, so we can also key off of LDAP groups as well. So we have auditable and repeatable endpoints and configurations. That's just the very nature of using a tool like Chef for configuration management. It's auditable in the sense that it's in source control. You can search for the configuration. You can look up any kind of value if you know what to look for. It's repeatable in the sense that as long as Chef is running and it completes 100% of the time, like your code's guaranteed to be the settings that are in the code. It's just the inherent nature of what configuration management has somewhat evolved to be in the last few years. We can also run the code on a continuous basis to catch regressions. We're not quite there yet, but we do have hooks into the Fabricator framework where we can, when Arcanus runs, it'll run some code liners, it can run some basic unit tests, so we can catch some regressions there. One project that we want to work on in the future is having a virtual environment that actually continually converges the code against a virtual machine or something. That way we can catch errors before it actually makes it into production and stop them really early. We also have a fairly robust endpoint monitoring and reporting. For that, we have the custom Chef handlers that I mentioned. We supplanted all the SCCM pie charts and stuff with that pretty much entirely. So all that involves is you take some data from the end of a Chef run, you format it in JSON, you push it up to an HTTP endpoint that we have internally, and then we actually have some fairly robust data pipelines that we can do analytics on. So we can get really pretty time series. We can generate bar charts if we want to. We can generate pie charts if we want to. We can do histograms. If you have a use for the data and you can collect it, it's simply doing an HTTP post to an endpoint and then learning some internal tooling that we have. We can also do deployments of agents because we're using configuration management. We can deploy agents that do performance metrics monitoring, post that data up into the custom HTTP endpoints as well. It actually works out very well for us. So here is an instance where we have some code that some idiot landed right about here. And as you can see, this is a ratio. We have 95% success rate, red line. We weren't having a particularly good day that day because it was always underneath it. But again, some idiot lands something, and we drop down here. And that just basically means someone broke trunk. Master is broken. So someone eventually submits some code here, and everything goes back, well, relatively back up. And the nice thing about this was we got an alert when it went down, and within, 10 seconds of getting the alert, the on-call's barking at some idiot, and that idiot was me. I did it. I broke Chef. But I knew about it really quickly, and I was able to submit a reversion diff right here, and then everything was hunky-dory again. We didn't get that kind of level of reporting with SCCM. You can probably subscribe to email alerts and know when things are broken, but it wasn't necessarily easy for us to set up that level of monitoring. We get this pretty easily with Chef, and that's a kind of a testament to how flexible it is. And then another key point when we were doing our development is we interface very frequently with our production engineering team. And those guys are awesome. They run the entire website at scale. So when we're talking to them, they introduce us to this idea of API cookbooks. So an API cookbook is basically a way for you to modify some very primitive data structures. A data structure like a list, a data structure like a dictionary or hash table. You're able to just set a few key value pairs or just add something into a list. And then there's some lower level orchestration that does a lot of the heavy lifting for you. So when we're trying to onboard teams, it actually becomes fairly easy to teach them these particular patterns. So appending to a list or modifying some key values, like anyone can do that if they have at least some like rudimentary documentation. So a good example of that would be, here's a user customization. This was one of my coworkers. He has a very specific setup for his environment. So he's actually a multi-platform guy. He uses Mac, he uses Linux, and he uses Windows. So if you're not familiar with Chef, this is just a Chef resource. It takes some values which correspond to registry settings right up here. And all he's doing is remapping caps lock to control. He didn't know exactly how the registry worked at this time, so I kind of left him to his own devices to figure out how it all works. But this little blurb right here is basically him taking a hex value, he's packing it into raw binary, which is exactly what the registry accepts for that, and then he pipes the data in, and then Chef sets it. And because he's on Windows, this is a bit of a Facebookism, but we also like monkey patch the node to make code a little bit more readable. So like this just does a check if the node is Windows. He also has configurations for Linux and Mac, so this is just the Windows portion because his file is actually pretty big and I couldn't fit it onto a slide. But the point is that this setting follows him everywhere. So he can actually get a new hardware, and then as long as Chef is running, like he will have his caps lock mapped to control. It's kind of cool. And here's like a very basic example of some user customizations. So the user customization a user customization using an API cookbook. This is a very simple thing that's just setting a screensaver timeout. So 300, I think it's in seconds, so that would be 5 minutes plus 1 minute or 1 second. He's going outside of the defaults. I think our default is actually 300 seconds or whatever. But for the most part, like he can set that setting, and that follows him everywhere. If he wants to set it to 1,500 seconds, he might get pinged by our security team because they do enforce some standards as far as what that timeout is. But that's a dual purpose. Like this guy can set it to what he wants, and then our security team can also look at it and go like, "Hey, dude, why are you doing this?" And if it somehow got past code review, like they could just run a grep and they could figure out that guy was out of compliance. It also would let us do automated testing on like establishing a compliance baseline. We're not quite there yet, but hopefully we'll get there someday. And then here's another one particularly for if you're a chocolatey fan. That's an API cookbook that manages the full stack of chocolatey as far as the client is concerned. This is just one component that's managing the sources. So you're setting it to whatever your internal chocolatey server feed is. It does other things. You could also set installs. It'll install them. It'll uninstall them. You can blacklist certain repos that match basically what that source would be. Like the API cookbook would intercept it and go like, "Hey, this is on a blacklist. I'm not going to bother applying this to the configuration." But the point of it is, like, you're doing a very simple thing here. You're setting a hash to a key value. Whoops. You're just setting a dictionary value, and then you're setting it to what you want, and that will follow you anywhere. If you wanted to add more sources, you would just create another thing with that, and then set the source, and then that would just be appended to the configuration. So that's all the nice, tasty things we have now. So what do we want to do still? There's a bit of an operational churn for us. Like we had that giant Equifax breach, and our InfoSec team went crazy. And there was also a pretty nasty patch Tuesday this particular month. But doing some custom patch management to reduce the operational churn, that's something we want to do. We want to maybe apply it with Chef. Maybe we might want to apply it with there's a resource in Chef that just installs Windows patches. We would really like to be able to do that in something that's outside of WSUS or something outside of SCCM if that's possible. So if anyone from Microsoft is in the audience, like you have the Microsoft Security Response Center API, which lets you query their actual CVE data. And it gives you a link to the Windows catalog to download things, but the problem is the catalog doesn't have an API. If it did, though, like we might be able to implement something that's Windows patching but without WSUS, which would be pretty cool. Something that's on our radar. Another thing that we want to do is operating system deployment. And that basically is when you get a bare metal machine, like if you're in the client space on CPE side, like CPE is, we have to provision a laptop. So what that entails is you have to wipe the drive, you got to put our custom image on it. That process can be painful and it can be very, very gnarly depending on what you use. We originally used SCCM, operating system deployment for that. It worked fairly well, but then our SCCM infrastructure wasn't keeping pace with what we needed it to. So we migrated back to MDT, a bit of a downgrade, but it actually is fairly more flexible than having to rely on SCCM. What we want to do is we want to get rid of that entirely. So there's actually a really good open source project from Google. It's called Glacier. Glacier is basically a way for you to do an operating system deployment, but everything is in code. The only problem for us is that it relies on Python. Getting Python into WinPE is not exactly the most fun way to spend your evening. We want to write something that's completely in PowerShell, just to reduce the amount of dependencies, because PowerShell is just built into Windows PE. Another thing that we really want to get going is infrastructure itself as code. Like there's been some really good talks on ARM. There's been some talks on using Terraform. We would like to do that kind of stuff too. It's really handy if you have to recover from some kind of disaster recovery scenario. If you just say like I need n load balancers and it provisions them and spins them up for you, like that's a really cool tool to have in your tool belt. And then another thing is we want to start doing performance optimizations on Chef client itself. So Chef is really cool and it's really flexible. It gives you a lot of rope to hang yourself with. It's so cool that there's this one thing that we use to manage Chef with. It's basically certificates. You can use a DSC with Chef, so there's an X certificate DSC resource. It's pretty cool, but all it does is it shells out to PowerShell, it uses the cert provider, and then it injects the certificates that way. We wrote a provider that does more or less the same thing, just in pure Chef code, but shelling out to PowerShell. The problem with that is that you do an idempotency check, and that takes up about 2 seconds. And then if the certificate isn't there, it'll spawn a PowerShell process, and that takes another 2 seconds. So if I have n number of certificates, it's like n times 4 seconds added to the Chef run. What Chef does actually in the tool itself is they use it's called foreign function interface. Most languages have it. It's a way for you to actually talk to a Windows DLL and call native Windows 32 API calls, which is super cool because the performance benefit to that is like insane. So I basically wrote a FFI interface into the certificate store, and then I did the same amount of like transaction, like installing root certificates, and then it ran a lot faster. So if there's anyone from Chef in the audience and you want to talk about that, like I'd be more than happy to. I have the code on my laptop actually. I could show you how I did it. But doing performance optimizations like that is really, really important because there's always someone that is affected by some kind of weird thing and they pop up the process table and they go like, hey, why is this thing consuming an entire core? And then they come to you and ask why. And if it happens to be the Chef client, they're more likely to just disable it because they think it's a performance impediment for them and to do their day-to-day. We want to avoid that. We want to get in, converge the code as quickly as possible, and get out such that they don't even know that we were there in the first place. Let's see, next. So these are just some personal lessons that I learned from this journey that I've been on. It's more or less just some best practices, like making this transition if you haven't made the transition to DevOps. There were some really good talks today about why you would want to make this journey because AI is going to take over your job soon in the future anyway, but you're going to have to train the AI, so you might as well just start thinking in a different way now. So you'll have to scale yourself as well as your infrastructure. So scaling your infrastructure, that's a pretty easy challenge to have, right? You just go into Terraform and you provision more things, or you go into AWS and say, give me more things, and it gives you more things. It's becoming really easy to do that. But you also have to be able to scale yourself. So one of the advantages of having API cookbooks is because we're teaching people to use these abstractions, it's actually a lot easier to get them to manage their own stuff. So one of the problems we had earlier on when we were rolling Chef out was people didn't necessarily they would come from a traditional background of managing Windows things. Like they would say like, oh, I need this group policy turned on. Well, we might have had the only access to turn those things on, but if they did it through Chef, they could turn them on themselves. Training them how to do that became actually more of a hard problem because, one, you have to train people that are in the old mindset. They have to learn a new thing. So providing them like those very basic abstractions actually was very helpful because we allow people to do their own stuff. So our security team actually does most of their own work on the client side. So if there's a vulnerability, like they actually can write the code to fix it themselves, which is great because who better to fix it than the people that actually know the most about it? We also have developers. Facebook's a big development company, obviously. So if they have to push developer tools, they know how to push it themselves. So it's actually much more frictionless for them to do the stuff themselves than it is for them to wait on us because our timelines might not necessarily align with theirs. Coding itself, like it's no longer optional. Like you can code very, very badly, but if you know how to code, like that's actually a step in the right direction. But you can't not know how to do it now. Like you can't not use you can't not know PowerShell and use DSC. You can't not know Python and use Salt. You can't not know Ruby and use Chef. You have to know just a little bit, and that's fine for now. But I would encourage everyone to like expand, like go out if you're not familiar with compiled, strongly typed languages. Learn a little bit of Go. Learn a little bit of C++. It may or may not come in handy. Like we encountered this really weird bug in the new Creators Edition of Windows where session 0 can't create symlinks because they changed the API for how it creates symlinks to let people do it unprivileged. I opened a case with Microsoft and I basically I wrote some C++ code and I said, hey, like I wrote this and here's the behavior I get. He was like, oh, that's kind of weird. And then he pasted back some C++ code to me. This is a seasoned guy. Like he actually knows all the Windows APIs, and it was like my 30 lines went to like 100 or something, and I was like, wow, that's some trippy stuff. But like I was engaging him in language he understood, and he was able to like help me get to the bottom of the problem. It was good to have a little bit of background in C++ to at least like point the guy in the right direction. And because like you're writing code now, you might have to learn a little bit more. So this was something I posted February 21st, 2015, obviously. I basically locked myself in my apartment for a weekend because I found the test development life cycle of writing Chef code was actually, it would take a while. So at one point in time, we were managing Windows 7, Windows 8, Windows 8.1, and Windows 10. So I had 4 VMs on my machine. If I had to test a Chef cookbook, best practice is to test it on every platform it's going to run on. So I would test it on 4 VMs, and it would take about, we were using Test Kitchen at the time, so it took maybe about 10 minutes to test each one, and my laptop at the time couldn't support running them all at once. So like to test one diff, it might take me an hour to actually run all the tests. So I was looking for a different way to do it. And the nice way to do a really quick red-green refactor cycle is to use behavior-driven development or test-driven development and use write unit tests. So Chef is really flexible in the fact that it's written in Ruby. Ruby has a really great unit testing framework called RSpec. And then there's a subset of RSpec specifically for Chef code called ChefSpec, coincidentally. So I locked myself in my apartment, and it drove me insane because learning RSpec was not exactly intuitive. The documentation, like I kept getting really old like Stack Exchange things. And then setting everything up just wasn't exactly the easiest thing. So I was like, it's driving me crazy. So within a minute of me posting that, my mom calls me and was like, honey, are you okay? Like, do you need to take a break? I was like, no, Mom, just coding. It's fine. But because of this, like, you'll have to think a little bit differently. So like if you're a system administrator or systems engineer, as my title is, you're going to have to like start adopting some software engineering practices. They're tried and true. Like they've been around a very, very long time. There's lots of really good resources like books on writing clean code, on how to do testing. It's very beneficial as a systems engineer because if you're going to rapidly iterate over things, like you want to provide people that, not just for yourself, but people that come after you that have to maintain your code, giving them a really good testing framework or just a set of tests is very beneficial because if they break something, they know about it. And that way they can iterate and have some peace of mind that they didn't break anything. Because if they push it into production and it goes down, like it really is a detriment to them. Like I wouldn't say like personally, but if they're constantly breaking things, they're less likely to want to contribute back. And then this is actually something that I was very surprised that's come up pretty much all day. Every speaker that I've attended, like they've always said this: embrace failures. Everyone does it. One nice thing that we have at Facebook is, and I've heard this story from a couple other people, is if there's a failure, like you go into, we call it sev review, so it's severity 1, 2, 3, 4, but it's sev review. So something broke, someone opened a sev, and then someone fixed it eventually, hopefully, right? And then we just go through every week. Every week we meet and we talk about it. And one of the principal things when you go into sev review is there's no fucking blame. No one gets blamed for anything. You're not there to blame something or blame someone for something, unless maybe they lost $1 billion, but you never blame that on one person in particular. But the acronym that we like to use is DERP, so detection, escalation, resolution, prevention. And then we just go over those bullet points and then try to prevent the failure from happening in the future. But no one gets blamed for it. And when you go through that process and you're embracing your failures, everyone pretty much is less, well, not less likely to break something. Everyone's going to break something, but you're preventing things from getting much worse in the future. And that's always been really, really helpful. And you know what? You're building up your team. You're trying to make sure that everyone can contribute back to the team. So just celebrating the fact that they broke something. I mean, I broke something. I showed you the graph. No one got mad at me. And people just laughed at me. A thing that we have on our team, we make them wear a cape if they break something really badly, which actually happened a couple days ago. So the guy's in Seattle, so we'll have to deliver the cape to him. So these are just a couple of some links. So we have our Facebook repo. So that's our public repo. I think we have another one with production API cookbooks. They're there for you to use. We do all kinds of stuff. If you manage, like most of them are geared towards CentOS because that's our platform of Poison. But if you do stuff in Apache, you have really good abstractions on managing Apache. It does modules and all that stuff for you. But all you're doing is setting key value pairs to manage it. The Chef Utils directory, like that's their philosophy doc. And then there's other goodies in there too. So I think there's a thing called Chef Cuddle. Like we actually don't invoke Chef directly. We have a wrapper around it written in Ruby, but the nice thing about it is it gives you hooks into different stages of a Chef run. So you can do pre-commit hooks, not in the sense of source control, but in the sense of a Chef run. You can run stuff before Chef runs, during and after. So it's very helpful. Here's Client Platform Engineering's GitHub. That has all of our APIs our API cookbooks for managing the clients. If you want to check that out, I think there's only one Windows one that I wrote. That's the chocolatey one. But this is really cool because the Mac community is very, very engaged with this. We've actually have a guy that works at Pinterest that rewrote one of our cookbooks, and then I saw someone diff it. We just copied and pasted his code into our environment. So it's a very vibrant community. So if you want to engage with us on our GitHub, like feel free. Like we'll accept pull requests. And then here's me on GitHub, SV Master Samurai. Funny story behind that name. Master Samurai is my Wu-Tang Clan generator name, and then SV just means Silicon Valley because Master Samurai was taken. And I think I'm totally gonna crush this because that's it. So I'll take questions, then you guys can go drink. Go ahead.
So has Chef replaced your need for group policy, or do you still have some stuff?
So that's a good question. I mapped out every group policy we had and gave it as a task for our team to like come along and pick up. Some of this stuff is fairly complex, like setting network firewall rules. There's no API provider, like either that we've written or built into Chef. That's a kind of a tough nut to crack. It hasn't supplanted 100% of everything. And then another important point is CPE and then CAT. Like we don't own the Windows stack. We actually are dependent on other teams. So we don't run Active Directory, another team does. So the traditional Windows admins on that team are actually more apt to use group policy to do that because they're familiar with it. We haven't completely sold them on using Chef everywhere. And that's fine. But for what we do, like most of it is all in Chef now, but not everything. Anyone else? Get out of here. Oh, go ahead.
One quick question.
Yeah, yeah.
Are your users admins of our machines?
Yes. Anyone else?
Thank you very much.